And we're back. So as we mentioned in the last video, which ended maybe 10 seconds ago for you, um, limits work great if you can just plug in the number and go. But what happens if you can't plug in the number and go? What happens if you're taking the limit of x squared minus 2x minus 8 over x minus 4 as x approaches 4? Well, when you try to substitute the 4 in, the numerator gets closer and closer to 0, and the denominator gets closer and closer to 0. And what the heck is 0 over 0? Well, 0 over 0 is something that we call an indeterminate form. It doesn't have a value. So what do? Well, lucky for us, in Algebra 1, they taught us that this numerator thing factors. The numerator factors into x minus 4 and x plus 2. And then the most glorious thing happens. These two factors cancel out. Now, why do they cancel out? Because we have a rule about division, about canceling, which really is division. So what is going on here? Well, we're taking a limit as x approaches 4. So we're not interested in what happens at 4. This factor is never 0. This factor is never 0, because we only care about what happens near 4, not what happens at 4. So these factors are never 0, and so we can cancel them. And then we take a look at what's left, and we say, well, golly, that can go in, and 4 plus 2 is 6, and that's our limit. So there are lots of limit problems that you can do by saying, okay, I can't plug in and get some number because I get 0 over 0, but if I factor, I can substitute, and then I'm okay. In a similar vein, what happens if we're trying to find the limit of the square root of x plus 6 minus 3 over x minus 3? How does that limit work? A limit of this fraction as x approaches 3. So a couple of things. One is that if you were to substitute 3 here, that goes to 0. That goes to 0. And so you're thinking, well, maybe some sort of weird algebra thing happens. Maybe some sort of weird factoring happens. Please promise me that you're not going to cancel out the minus 3's. You can't do that. Those are added terms. They're not multiplied terms. So you can't just lop off the minus 3's. That'd make life easier, but it's wrong. So here the thought is, to get ourselves out of trouble with a radical, we actually multiply and divide by the same quantity. And that quantity is going to be the conjugate of this numerator. The conjugate of the expression with a radical in it. So you learned in high school that conjugate means that we just write the thing as it was, but we change that sign. And then we multiply and divide by that expression. And so you may be wondering, why would we do this? It looks like it makes things more complicated. I mean, the denominator is this hideous, awful business. And I agree with you, it looks ugly in the denominator. But the numerator, oh, check that sucker out. That's x plus 6. Those drop out. That's minus 9. So what's x plus 6 minus 9? Think that through, folks. Oh, looky there. Now I've got those drop. And once those drop, well, I don't know why that's not writing anymore. Once those drop, Those are gone. This factor goes to 3 plus 3, that's 6. And so we end up with 1/6. And that should say 1/6, and it doesn't, and I'm not sure why, and that's a problem. I'm going to hit pause for a moment. Yay, it turned out it was writing all along. I'm so glad I hit pause. Okay, that's marvelous. I'll show you one more technique that you are going to want to know, and this will help us to find the limit of 1 over x plus 3 minus 1 over 5 over x minus 2 as x approaches 2. And again, you should confirm for yourself that substituting 2 ends us in a 0 over 0 situation. Nobody wants that. And so what we do here is we think about, well, wait a minute, this is a fraction and another fraction within a big fraction. So we're working with like a complex fraction. It's called a complex fraction. And the least common denominator for those two terms is 5 times x plus 3. So let's multiply numerator and denominator by 5 times x plus 3. Why numerator and denominator? Well, because that doesn't change the value. What we're basically doing is multiplying by 1. This fraction is 1, so we're not changing the value. So what does that mean for us? Well, it means the denominator is actually not that bad. It's just a product of 3 terms. But in the numerator, as we distribute 5 times x plus 3 times 1 over x plus 3, that's 5. And 5 times x plus 3 divided by 5, that's just x plus 3. Well, what's this? Well, this is 2 minus x. This is 2 minus x. This is x minus 2, which means that these cancel because x is never 2, so these are never 0. But a 2 minus x and an x minus 2 leaves behind a factor of -1. And so what's that limit turn out to be? Well, if x is 2, this gets closer and closer to 5. That's always 5. 5 times 5 is 25, and that turns out to be your limit. You should consider the following things before we gather. You should think about the limit as x approaches -3 of x squared plus 4x plus 3 over x squared minus 9. You should try to find the limit as x approaches 5 of the square root of x minus 1 minus 2 over x minus 5. And the limit as x approaches -3 of 1 over x plus 2 plus 1 over x plus 3. This is a factoring question. This will use the conjugate. This is a complex fraction problem. And then if you're thinking about other questions that you might want to know how to do, find section 2.3 in the Strang Herman PDF and check out questions 83, 89, 93, 97, everything from 107 to 110, 115, 121. Okay, we'll see you in class.